Note that you can change any numeric variable to a string using str. So that's one way you can deal with the inconsistencies between data types when you're trying to join them. On the other hand, you can't make a string a number. So that's going to always get you in trouble. Right. So if I run this after I save it, again, it produces the same output. I would argue the F string is easier, and I would suggest that's probably the way you want to go. Okay. So let's go back here. Okay, so we mentioned these before. These are escape sequences, and the purpose that they serve is to allow you to perform certain operations within strings without confusing the compiler. And the way you do it is you precede the escape character with a backslash, and the backslash tells the compiler that the character that follows means something other than a member of the string, right? So backslash n gives you a new line. Backslash t will tab it over. Backslash t is very useful when you're trying to format output, and you've got to play around with it a little bit. Backslash r return, and I'm not really sure what that does. Backslash double quote will add a quotation mark in a already double quoted string. Backslash single quote will add a quotation mark in an already single quoted string. And backslash, double backslash, just add the backslash to the string. Okay. So for example, backslash n is similar to pressing the enter key in the middle of a string. And again, escape sequences are needed so the Python compiler can interpret the code correctly. If you have, since single and double quotes are used to identify strings, if you code them together within a string, this can cause syntax errors. But if you repeat, for example, the double quotation marks by an escape character, the Python compiler can interpret them correctly. Okay, so
Dr. Hibona?
Yes.
How many spaces does tab go, and do you have any control over that?
Yeah, that's a good question. I'm not sure. It's either 4 or 5. I'm not sure with each successive backslash tab. You've got to play around with it. I'm not sure if you can actually control it with some sort of additional argument, but generally you have to play around with it to make it look the way you want. Okay, so take a look at this. This is slide 18. Right, so here we have just a single string. Here's a new line escape character. Here we have a similar string, but we have a couple of tabs in here, and then a new line character on this side, and we have another tab here. So let's take a look. So we run this. And for the first one, we get this output here. Note that it has simply put the spaces in. And it has thrown the line here just before quantity because of the new line character. In the second one, okay, and this is what I mean when I say you have to play around with it. In the second one, we want the output to be to look nice, to be tabbed over the same amounts. So you just have to play around with it. Here we have 2 tabs to move this over this much, and we have 1 tab here to move it over this much. Let's see what happens if we change this to just a single tab. So it appears that a normal tab, I believe, is 4 spaces. In this right here, it's hard to tell. And here we have, there's some defaults in there, so it's not consistent. So you really just have to play around with it to get it to look nice. Okay, let's see, put those back. And I encourage you to do this in your exercises, your upcoming exercises. You want it to look good for the user. So tabbing can help you do that for sure. Okay, so let's take a look at this next one. Okay, I would encourage you to play around with this a little bit. These just provide examples that we've seen already. But if you have any doubts about how these string operations work, this is really a good time, or after class, a good time to play around with this, do some experimenting with them. You're going to get a few error messages, but each one should give you a better understanding of how Python works. For example, you can tell what's going on down here. This first one is a syntax error. So you would get this when you try to compile a program. It doesn't know what age is. And no, it's a syntax error, actually. You should have some pluses here. Age is defined in the previous line, but there's no plus before it, no plus after it. So it doesn't know what it is. So there's a syntax error here. You're getting an exception. You're getting a runtime error because you're trying to concatenate a string. You're trying to concatenate a string to an integer, right? And you have to, in order to get that to work, you have to change the integer into a string using the str function. Okay, so I'm sure you'll encounter some of these problems when you actually run some of your programs. But as I say, really the only way to learn how to program is to do programming. So practice is good. Practice is your friend. Programming is really the only way to get good at this. So this is just a review of things you can do with the shell. Again, you're just running one statement at a time in the shell, and you type it in the prompt and you press enter. You can also type the name of a variable. You don't have to use print at the prompt to see what its value is. In fact, when you type a variable name in the shell, it intrinsically calls the print function. Variables that you make remain active in the current session. So they're always floating around and available to you in your space. Alt P enables you to walk back through statements, and it's Command P if you're using a Mac. Okay, so let's look at some relevant Python native functions. Okay, so here we're using print, and this first print receives the 4 arguments, right? Total score, comma, which separates the first and second argument, total score total, which has already been defined somewhere, we implicitly continue this line with a comma, and we come down here and we use new line character, average score. Let's give this a, see if we have this. We do. We have this on the slide somewhere. So let's take a look. So we've defined total score 240 up here, and then average score is 80. And note this print just simply serves to throw a line. In this case, we're just running it as 2 F statements. Okay, so this is 2 different ways to get the same results when using print. First print function receives 4 arguments. Let's run this.
Do you have to use 2 F statements, or could you have done just 1 F statement?
That's a good question. Let's try. You mean like this? Something
Yes.
like, okay. Yep, that works just fine and it's simpler.
Wow.
And probably the same with this as well. Well, this, yeah, this one we're just implicitly continuing it with the comma, but you don't have to do that either. I don't think. I believe this will work just as well. Yep, sure enough. Okay, so they're just saving space here.
So there was no real benefit to using 2 F statements instead of 1.
No, no, there isn't. And the F statements are simpler, right? As you can see here as well. Okay. So we have that. Here's some more examples of print. With changing the separator in the end. So if we just do print 1, 2, 3, 4, we'll get just 1, 2, 3, 4 was separated with a space because that's the default value of separator. If we change separator, the default value of separator to be a space and then a bar and then a space, it will put that in between each argument. The other argument to print that we can manipulate is the end. Normally end is the default value is a new line character, new line escape character, which causes a print with no arguments to print a blank line and to have the next printed line turn up on the next line. But we can change that. We can say end, I want this, I want the value of the end to be this. So what else can we say? Print function can accept 1 or more data arguments. When you pass a series of arguments to print, numbers don't have to be converted to strings. If you pass just 1 string as the argument for print, then numbers do have to be converted to strings within the string argument. Right? If you have age, for example, as a number and you precede that, let's try this.